So we're going to have a look at the features of the VIT module. I'm just going to open it up. To get the most out of this, you will need to use the data set called small sample. So we're going to come under the Bootstrap confidence interval construction and run the VIT mode. And I'm going to import the data. So I've again saved it onto my desktop. Where has it gone? Small sample. And okay, so there's only 40 pieces of information here. It is just randomly selected. Okay, so for this one, we are going to have to again look at gender and income, or gender and hours, it doesn't matter which. And you can see that there are only a very few pieces of information there, because I wanted you to see what the VIT module is doing, and I wasn't interested so much in how the sample represents the population. So this is just about the mechanics of what this piece of software is going to do. If you click under Analyze, we're going to change that up to Median and record my choices. And in this particular sample, the males earn $374.50 more per week on average than the females in the sample. And so what we're going to do is we're going to have a look to see if that difference is significant enough to claim there is a difference back in the population. And we're also going to try and put numbers or quantify what that difference is. So the first thing that this module does, it takes the sample that you import, and it says, okay, let's assume that that sample is representative of the population. And so we will use that sample and we will repeatedly resample this group as though it were the population. So in a sense, you've got a female here that earns $3 per week. We'll assume that there is an unlimited number of females who earn $3 per week back in the population. There's a male here who earns $1,090 per week. Let's just assume that there is an infinite number of those males back in the population. And so we're assuming that the population looks like this, and that there are heaps of these people back in the population that we can keep asking, what's your weekly income? And they'll say, I don't know, $74 if it's this particular female. So I'm just going to animate points so we can see where our new sample is coming from. So let's go. So there is a female, that female is being chosen to be in the resample. It's going to keep selecting people from our sample. Remember, our sample is standing in for the population, and it's going to be recording them as a new sample. We'll just wait, it's going to go a little bit faster. It'll then go through and show you how many times each person in your original sample has been selected. So we'll just wait for it to do its thing. You can see that we have the same number of people in our resample. There are 40 people there. There might not be the exact same number of females and males, but that female there has been chosen 4 times. But that's okay, because we said that back in the population there's an unlimited number of these females or males. There's an infinite number of them. So they might get chosen once, they might not get chosen at all. They might get chosen 6 times to represent 6 people who are just like them. So hopefully it will go a bit faster. It's just going to go through each one and show you how many times it's been selected and where that appears in the sample. And then we will have a look. You can see here that there's a red arrow which shows the difference in median income. That red arrow is going to be dropped down on here. And that next. Okay, it's really slow. I'm actually going to stop it. I'll let you play around with this a bit. So if I go down onto this next part, include bootstrap distribution, I'm going to click on go. So you can see the sample being selected and where that's coming from. Remember, some of these data points might be selected once or more than once. Once our resample has been calculated, iNZight will find the difference in the median income. There it is, there's the difference in median income, and it's going to drop this down and it's showing up as one little dot there. That represents one difference in median incomes for one resample. If I do this 5 times, go a bit faster, that's where the females had a greater median income, sometimes they do. There has the female having a greater median income again. This is where all the males have a greater median income. And you can see that for every resample that's taken, another little dot appears on here. And this bootstrap distribution, right now we've got 5 dots on it, and they represent 5 different resamples, 5 different samples taken from the population. And we can see that mostly the males do earn more than the females on average, but sometimes it's the opposite way around. If I run another 20, we'll build up a better picture, so you can see it goes faster and faster and faster. Remember that each one of these tiny little dots represents a difference in median. So overwhelmingly, most of the samples are finding that the males have a higher median weekly income than the females. If I run this 1,000 times, you will see a picture building up. And most of the time, you see almost like a normal distribution. It should be fairly normally distributed. They're not always. We're not so worried about the shape of this. We're more worried about what is happening most of the time. 95% of the time, do we find that males earn more than females? So down here, I can actually show the confidence interval. What it does, it drops down our original difference in median. So this is our original sample. So we found that males in our original sample earned $374 more, $374.50 more than the females in that sample. But this is saying that actually back in the population, that difference is not significant enough because sometimes the females can earn more. And a 95% cutoff is showing us that actually females could earn $131 more on average per week than males, or it could be the opposite way around, and males could earn $589.50 more than females per week on average. And because you get both situations, females earning more and males earning more, then you actually can't say for sure that back in the population that the males will earn more than the females. Okay, that's what this bootstrap distribution is showing you. I'm just going to go back and I'm going to load up all of the data. So where did I go to? Data. Because that was just a really, really small sample. So if I go back to, where was it? Desktop. And I just called it pay equality data set. So this is all of them. Sadly, you won't be able to see the beautiful creation of the sample, of the resamples. Sorry, I need to select gender and income. So we'll have a look with with more data. Can we actually say that there's a difference or not between the weekly median earnings of males and females in New Zealand? So once you get the hang of this, I mean, you can have a play around with these sections here, but I'm just going to flip straight down to 1,000 just to see if there is a difference or not. So you can see with this one that actually a lot of these differences in median incomes are much smaller, and there's very few of them that are deviating where the females earn more on average than the males. So I'm expecting to see an actual difference in this one. Let's click on Show CI. So it's going to drop down again the observed difference, and then it's going to calculate the confidence interval. So the 95% confidence interval. So we can say that males, because there's no negative and positive value, they're both positive. On hardly any of the samples did females earn more on average than males. You can see perhaps just one down there, one random resample. This is saying that 95% of the time males earn between $110 and $282 more than females in New Zealand on average every week. Okay, so this is saying we can make a claim at population level that males do tend to earn more than females, and that difference is somewhere between $110 and $282 more per week, which is like massive. Obviously, if this sample that we took, that we were given, this sample of 500, if that is not representative of the population, well, the whole analysis breaks down, because the assumption is that whatever sample you are putting in is going to be representative of the population. So you can just keep resampling from it with replacement. Okay, so you must be able to say that your sample is representative of the population, otherwise the whole analysis breaks down. But that's how to use iNZight, that's how to use the VIT modules.